Hey everyone, welcome to check out self-service data governance using the DataHub Action Framework. So who are we? We're an end-to-end payment service provider. Some of our customers include Financial Times, Shane, General Electric, Sony, Patreon, and Wise. We're a global company. We're headquartered in London, UK. And Matthew, Cloudert, and I are like data engineers here at the data platform team. And we work mostly in the data governance side. So what's our goal as a data governance team? So one of them is to provide clear ownership for data sets, and to give them like data stewards and owners. Second is to provide data discoverability, so giving owners the tools they need to document and share their data. Compliance to enable our operational use cases, such as PII tagging and data deprecation, which we will be talking about in this presentation. And last but not least, insights to help data consumers to quickly find what they need and derive insights from it. So what's our data stack? So at the moment, we really follow a modern data stack. We use Kafka quite a lot now as we move towards more a streaming platform first approach when it comes to ingesting data. We use Snowflake as our data warehouse, and we use dbt and Airflow for our transformation layer. And we use Looker for our data visualization. So why do we use DataHub Actions? The most important bit of why we use it is to allow us to make real-time changes as soon as an event happens in DataHub, either through the UI or during the ingestions. And two main important use cases that we use it for is to classify columns as PII, and also to remove unused data sets that we have in our data warehouse. So two pool-based ingestions that we use the DataHub Actions for is Snowflake and Looker. Whereas with dbt, LookML, and Airflow, we use it more as a push-based ingestion. But we still use DataHub Actions to consume whenever an event happens and do any use cases for it. So deprecating an asset, what's the problem? So in our data platform, we currently support about 42 teams now, and it's still growing. Our data storage is constantly growing as well. Each team has the more team we onboard, the more team requires a lot of ingestions of data. And because we have a lot of data being ingested, it's very quick for data sets to become stale and unused very quickly. And then people are constantly chasing us, oh, can we use this data set? And so forth. So the way we've kind of designed this is that we use the DataHub Actions to facilitate our automatic deprecation, and based on the update of the deprecation, we then provide users a way to view their deprecated assets through like Looker dashboard, and also give them the necessary decommissioning documentations so that they can delete their tables and the upstream pipelines for it. So how does the automatic deprecation works? So essentially, we've built a detection model, and then during a Snowflake ingestion, which we've kind of hooked it up into one of the DataHub ingestion transformers, a custom one that basically checks like the value of a specific Snowflake tag, and depending on the value of that, we update the deprecation accordingly and automatically if it's not already been deprecated by the user. And the conditions when a data set needs to be deprecated. If it's not been read in 30 days, we consider it as unused. If it's not been read in 60 days, we consider it stale. And at the end of it, if it hasn't been read in 90 days, the data set then becomes liable for decommissioning. So this means removing the upstream pipeline and also the table itself. We also provide users a way to de-deprecate something. And that means that if a data set becomes verified, this means that a verified data set being, if it has a full documentation onto it, if it has clear ownership into it, and so forth, that data set then becomes protected in some case. In the other case, that a data set can be deprecated if it has been read once in the past 30 days. So the conclusion of the whole deprecation aspect. So the benefit is that we save a lot of costs because we decommission the upstream pipeline at the table. We declutter our data warehouse, so this improves user experience. And also, this increases operational efficiency because we avoid maintaining any asset that should not even be used anymore. So we're still very excited on what can we extend the DataHub Actions for. So we have got a lot of plans still. One of them is to essentially extend the detection model to not just do it for not read, but also extend it in a way that to target specific niche cases and provide a way to give that to stakeholders and give them a way to approve specific deprecations. The other case is that we want a fully automatic decommissioning, meaning that at the moment, everything's a bit manual when it comes to decommissioning. So we want to do that in a programmatic way, automatically decommissioning the upstream pipelines. And last but not least, DataHub native. We want to move away from Looker dashboards and build everything on top of DataHub natively. I'm going to pass this on now to Matthew, talk about PII and roadmaps.
Yeah, so the problem we're trying to solve is we're trying to give data owners and stewards an easy way to match their PII data sets, no matter where it comes from. So they could be marking it in DBT in the meta mapping, or they could be marking it in the schema registry in Kafka. But no matter where they are saying it, we want to have one central place to store that information. So we've used the DataHub Actions Framework. We've created an action, which is basically just a Kafka consumer that listens to any change that happens in DataHub. And whenever the glossary term PII is added to a column, masking is propagated down to the source. What else we're working on with this is we have an automated detection mechanism to scan our data sets. And if potential PII is detected, we'll grab the owner from DataHub and send them a Slack message asking them to review. So this is kind of how it works for Snowflake. In Snowflake, we have an account level masking policy that masks any column that has the Snowflake tag PII on it. So whenever a glossary term is added into DataHub, an event comes into that Kafka topic, and then we parse it. And if a PII term was added or removed, then we propagate that masking down into Snowflake and also send the person who did it a Slack message confirming it was successful. And then the data was masked. So what are these events? It's a big JSON blob. It's not that friendly. It doesn't look that friendly, but it's not actually that bad to work with. So any event that happens in DataHub, whether it's a new table is ingested or someone added a tag to something or a glossary term, it sends one of these into the Kafka topic. And it contains the previous state and the new state. So we parse that to see, basically, we look at the new state and we see, is there a PII term that exists now that didn't exist before? And if so, then we propagate that down to the source. We can also audit this really easily. We replicate the MySQL database into Snowflake, and then we've done a lot of aggregations on that to see, we can tell who did it, when they did it, for everything that's ever happened to DataHub. So all this is really auditable downstream. So here's a little functionality demo of how it works if you're an end user. This is just doing it through the UI, which isn't the way we like people to do it, but it's easier for a demo. We'd rather people document whether something's PII at the source. But here we have a table that's not masked. If I add the PII glossary term, that Snowflake tag is added in Snowflake immediately, and you can see that it's immediately masked. So if they change their mind and say, oh, I've made a mistake, it's not actually PII, they go in and remove it, then that masking is again propagated and it's no longer masked. So how else do we use the actions framework? Those were two examples. We use it a lot. One is we have data quality rules. So one example of that is for uniqueness. We check, does this data set have a test for uniqueness on it? And is that data set passing? And since we use the actions framework, we get that information in real time. So people can see in DataHub, it'll have a little X next to it. That accuracy is failing or uniqueness is failing right now. So maybe go ask the owner for this, or maybe consume from something else for your use case. Another thing we've implemented is domain inheritance. So whenever a domain is added to a container object, or Snowflake database or schema is a good example, all objects within it inherit its parent's domain in perpetuity. So for the use case where you have a DBT project that's all in one database, and you have hundreds, some are maybe 500 tables in them, you don't have to go through and manually add it. And every time you add a new table, it automatically inherits that domain. Another one we've done is temporary PII access. So owners of the data set can add the tag of the form PII temp with the username and the date that grants the user temporary access to read mass data within that column or table until that date, and then we remove it. So now that you've seen some examples, this is how you write your own. So first, you have to have a Python package where the logic for these actions can be stored. And then you create a custom Docker image from actual DataHub Actions base image and install your package onto it. We then push that image to an image repository like Docker Cloud or ECR. We use ECR. And then modify your DataHub deployment. For us, that's a Helm chart. Since we use EKS, we use a Kubernetes deployment. Then you pull the image from there rather than from the actions pod that Docker provides. So what challenges have we faced on doing this is, first, we trialed an opt-out PII policy using automated detection to mask PII for stakeholders. People didn't really like that, because even if you have a 99% accuracy, if you have 50,000 columns, then that's still a lot of mistakes, so a lot of data that's masked unnecessarily. So we've instead moved to a detect and notify strategy. So we suspect PII, and then we'll send them a notification rather than doing it for them automatically. Another challenge we face right now that we're looking at resolving with the actions framework is currently all our data access requests go through the central team. So we might have to talk after this 𝗘𝘅𝗀 about the stuff that they're working on at PayPal. But we're currently implementing a solution that allows data owners to manage access to their data sets via DataHub by leveraging the actions framework. So people will be able to make a change to a policy of who should have access to this data. And then it automatically implements that in the source, whether that's Kafka or in Snowflake or Looker. So that's it. Thank you very much.